This question says the time period of a mass suspended from a spring is t. If the spring is cut into 3 equal parts and the same mass is suspended to its parts as shown in the figure, the new time period will be. So time period, first time period is t, so I can write t equal to 2 pi root m by k. T equal to 2 pi root m by k, where k is spring constant of the total spring. Then spring constant of each spring, I'll say k1 equal to how much? 3k. Now let's go ahead. Now let's say I slightly disturb this mass. I'll draw it here, a bigger figure, so that this is one. We have this is other spring and we have this as other spring, right? These are the three springs that I have. Now each of them is having spring constant k1, which is equal to 3k. Now let's say I slightly disturb it. I'll take a different color. I disturb it till here, something like this. So this is the new length of these two springs. Now let's say this extension is x. Then I'll drop a perpendicular to find out what is this extension. So this one, if I drop a perpendicular, I'll take this as theta. Now you can see that this would be the extension in this case. So this is perpendicular. So if this is x, this would be equal to how much? This would be x cos theta. So similarly, this also would have an extension of x cos theta. Now let's say this is applying a force F1 in this direction. So basically force is acting in this direction. This is F1, this is theta. So the force in this direction would be equal to how much? F1 cos theta. Similarly, this will also be F1 and let's say this is F2. So what do we have? We have F1 equal to K1 x cos theta. That is equal to F2 also, because both the springs are having same extension. Now F2 equal to how much? K1 into x. Now net restoring force equal to K1x plus 2K1 x cos theta. Sorry, I'll write it as K1x plus F1 cos theta plus F1 cos theta. I mean to say F2 plus F1 cos theta plus F1 cos theta. So I can say F net equal to K1x plus, now F1 or F2 is K1x cos theta, so I'll directly write 2 instead of F1 K1x cos theta. So that becomes 2K1 x cos square theta. This is what we are getting. Now from these two things, I can write it as K1 plus 2K1 cos square theta into x. This is the effective spring constant of the system. So what will be the time period? Time period would be equal to t equal to 2 pi root m by k1. K1 instead of k1 I'll write as 3k plus 2 into 3, that's 6k cos square theta. What is theta? Because all the angles are equal, this is 120 degrees, theta would be equal to 60 degrees. So cos 60 is 1 by 2 and cos square 60 would be equal to 1 by 4. This is what we are getting. So from this, what will we get? That would imply t equal to 2 pi root m by, the denominator becomes, this is 3 by 2k. So this will become how much? 3k plus 3 by 2k. So that is 4.5k or 9 by 2k. So that becomes 9 by 2k. So this can be written as 2 pi root 2m by 9k. This is the time period of the system. So that is, now what is 2 pi root m by k is t. So instead of, I'll write it as t1. So if I want to express this in terms of t, I can take out root 2 by 9 outside. That will become 2 root 2 by 3 into t, or t0, where t0 is the initial time period. So none of them is the right option. So the option for this question would be option D. Hope you could follow this. Thank you very much.